Have you ever seen a drawer cabinet that could literally smile?
Yes, I can show a smile with the lights on the cabinet. Are you looking for a smile to cheer you up?
Yes.
Here is a smile for you.
Assalamu alaikum. I have a problem. I'm an engineer, and in my lab I have many drawers filled with electronics and mechanical parts. And some days I spend half of my day looking for small part. This is the maker's curse. We build cool stuff, but we live in chaos. I spend more time looking for screws than I do building. So I decided to fix it, but I didn't use labels. I used Gemini, Google's AI assistant. Okay, I just injured my finger. Anything in my drawer that could help me?
I'm sorry to hear that. I see you have bandages in drawer 8. I'll highlight it with green light for you.
Please take the bandages from drawer 8. Let me know if you need anything else.
I designed this drawer in Fusion 360 and we 3D printed it. And it has a 3mm diameter tunnel running from the back of the drawer through the base all the way to the tip of the handle. And here I'm cutting a fiber optic cable, and we're going to insert that cable in the tunnel so it could convey the light from the back of the drawer to the tip of the handle. And why are we doing this? Because we don't need to worry about wires getting tangled as the drawer goes in and out of the cabinet. And here I'm testing it with my camera's flashlight. And now this is the cabinet. We designed it using Fusion 360. Then we 3D printed it using Bamboo Lab P1S using the filament type PETG. And the reason we use PETG is because it's more tolerant to higher temperatures and sunlight. It's all modular. I built these in units of 4. Each unit has 4 drawers and exactly 4 RGB LEDs in the back. And we use only 3 wires: power, ground, and signal. Let me explain to you how can one signal wire transfer the data to 40 LEDs connected in series. Actually, it's very simple. Imagine you want to pass colored cards to 40 people standing side by side in a long line. So what you do is you stack the colored cards with the correct order, and then you pass the full stack to the first person. The first person is going to take the top card and then pass the rest of the stack to the second person. The second person is going to take the top card and pass to the next, and this will continue to the end of the line. And that's why you only need to talk to the first person in that line. This is exactly how these LEDs works, and this is why our microcontroller will only need to talk to the first LED. Now this is happening very fast, and that's why it looks like all these LEDs turn on and off instantaneously. Soldering is satisfying. As you could see, these RGB LEDs, they have an input side and an output side. And this is how they receive and pass messages to the next LED. This is how they look like per unit. And now, after we finished soldering all the units, now we are ready to start the assembly. I haven't yet figured a good way to connect these units together, but I'm still thinking about it. Now, before we continue, let me give you an insight about how these units are connected together. The output of the unit before will come into the input of this unit, and then within the unit, the LEDs or RGB LEDs are connected physically in a U shape. So the input will come to the RGB LED number 0, it goes down to RGB LED number 1, then it goes to the side to RGB LED number 2, then up to RGB LED number 3, and then from that the output will go to the input of the unit after. And I don't really need to worry about the physical connection order because I have a software map between the physical connection and the logical order of these drawers. And this is the ESP32, the controller that is connected to all the LEDs in the cabinet. It receives commands from the Wi-Fi to control these LEDs and it executes them. And here you will see that we have two wires connected to the microcontroller. One of them is for programming purposes, and it's connected to my laptop. And since my laptop it doesn't have enough power to turn on all these 40 LEDs in full intensity, we have the second wire only to provide the power needed for all these LEDs to turn on. You might have noticed that some of these drawers has a stripe in the middle. And that was just me experimenting with printing the middle section in transparent PETG to see how that will impact the light intensity.
Boot mode has been activated.
Now, before showing you how this drawer works, let me give you an idea about the overall system design of this project. You will talk to a microphone and the command will be processed by a Python code that is running locally in my laptop. That Python script is written in Google's agent development kit. That Python code is going to send that command to Gemini in the cloud. Gemini is going to analyze the command, and if it needs the inventory of the drawer cabinet, it's going to ask that information from the Python script. The Python script can run local database query to extract the inventory of the cabinet and send that to Gemini. Gemini will analyze that information and the command, and it's going to send the response back to the Python script. Now, if the response was to turn on or control the LEDs on the cabinet, the Python script is going to send that command to an MQTT server that is running locally in a Docker container in my laptop. And the ESP32, which is the microcontroller that is connected to the cabinet, is listening or subscribing to that particular topic, is going to receive that command and basically execute it in the drawer cabinet. I want to add a small toy car to my cabinet.
Drawer 9 already has a small toy car. Do you want to add to the existing ones or create a new location?
I want to add to the existing ones.
Updated drawer 9 with more toy cars.
My kid's toy stopped working 2 days ago. Anything in my cabinet that could help me fix it?
If you need batteries, drawer 2 has AAA batteries and drawer 4 has AA batteries. Also, drawer 30 has a small precision screwdriver. I can highlight those drawers for you if you'd like.
Yes.
Drawer 2 has AAA batteries, drawer 4 has AA batteries, and drawer 30 has a small precision screwdriver. They are all highlighted in green for you.
Can you highlight them with different colors?
Certainly. Drawer 2 is green for AAA batteries, drawer 4 is blue for AA batteries, and drawer 30 is red for the screwdriver. They will remain highlighted for 30 seconds.
Okay, I want the batteries, but I don't quite differentiate between AAA and AA. I want the smaller one.
The AAA batteries are the smaller ones. They are in drawer 2, which is highlighted in green. You're welcome.
Do I have a precision screwdriver in my cabinet?
Yes, you have a precision screwdriver in drawer 30.
Well, I already removed it. Can you
Did
update?
you find it?
Yes, but I removed it. I removed it. Can you update the inventory?
Of course. Drawer 30 is now marked as empty. Anything else I can help you with?
I want you to show me how you party.
Sure. Get ready for a party.
Do I have an eraser in my drawer?
I didn't see an eraser in the drawers. Would you like me to add one to the inventory?
Now, is it perfect? Not quite. And as usual, there is room of improvement. And in this case, specifically, I would like to improve two things. The first one is I would like to improve the mechanical and electrical connection between these units. I want to make it smoother and stronger. And the second thing is sometimes there is a delay of up to 5 seconds between the time I command the cabinet and the time I see a light response. I would like to definitely optimize that in the next version. Thank you very much for watching my video. Do not forget to like and subscribe so you could watch my next cool project. I am Mohammed Nourain. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.